This is where I sit.
Can't see them.
Well, I guess we could probably take Zozo, Zebra, see. I would never come back.
I don't know.
She's like going away this summer, so she's probably like spending time with her boy toy.
No, she's here.
Oh, really?
Yeah.
Oh. So,
You want to see her?
Talking about
I didn't say it was a bad thing. This is probably what she's doing.
She's waving.
Oh.
All right. There's my arm. That's kind of up close and personal. All right. We're going to go over right triangles today. Well, what I was saying was that you have late passes, so if you need to use those, go ahead. I would not plan on using those unless you have to. I would try to make sure that you stay current, because we're now sort of, especially for seniors, but for everybody too, we're at the end of the year. So planning on doing things late or getting them in late, it's not a good idea. I would just try to get everything out of the way. We had 4 homework assignments before the test. So for 100 points each, that's 400 points of your grade. The last test was 500 points. We're going to have 3 or 4. Well, I'm not sure about seniors, so we'll just go as far as we can with the seniors. I don't know where the test will be. Seniors will just go until it's time for you to leave, and that's as far as we get, I guess, with you guys. But for other people, you should probably have 4 assignments left. And if we can fit in a test, we'll do one last test. So if the homeworks, if we have 4 of them, will be another 400 points. So if your grade is down, that's an opportunity to get them up. And if there's a test, that'd be another 500. So we'll see how far we get. But just keep in mind that if your grade is lower than you'd like, get those tests in, get those homeworks in, stay current on them, and that can help you. In any case, don't just leave them and expect not to do them. Okay, so to go over the right triangles, hopefully this will be somewhat of a review for you. Hopefully you remember this from last year. You should have done at least right triangles last year. So we're going to start by going over what we know of right triangles. And then in future classes, we'll talk about a couple of other ways to solve triangles using what we call the law of sines and the law of cosines, which may be new to you, which is okay. So I'm going to share my screen and go over that with you. Okay. All right. So we're talking about right triangles. So just to review geometry a little bit, if you have, where's my line? What the heck? Let me run this again. I don't get it. I was just using this. Let me try a different program, I guess. Of course, it would fail the second we start something.
Wait, hold on. So, since I'm trying to use my brain for a second. Miss Cook just sent an email saying the final was on the 17th. Obviously, school on the 17th. So, are finals starting next week, or is it just Miss Cook being like, ah, fuck you?
Finals are next week.
Alright.
For
So,
yeah.
hypothetically speaking, after I kill this presentation and I have an A, would I even have to go to school?
No.
The next 2 days? Alright.
Not if you don't have a final.
Actually, 2 days next week, it's like only if you happen to be in the class.
Well, what I'm saying is I have a final on Monday next week.
You probably have to take that. Unless, well, I don't know. You probably have to watch people.
Because she literally did stuff to help me get my grade up to an A, so I wouldn't have to take my final.
I would just sit there and watch people take it. What's your thing?
I mean, honestly, I'll just watch like YouTube videos of it.
You guys ready?
Yeah.
All right, let's say we have two parallel lines like you would have had last year in geometry class. What would we call this line that crosses?
Angle of elevation.
That's not a bad thought. That's not what it's called, but that is a relevant topic to what we're doing. What is that line called that crosses?
But
Starts with a T.
transversal.
There you go.
Oh.
Very good.
I didn't know that.
We have a transversal line. Anything that you remember about the angles formed by a transversal line crossing two parallel lines?
You want us to say them?
Yeah.
I know that the top left thing right here and the bottom right one are the same thing.
Which one? This
So,
one?
Yeah, that one, and then the very bottom right one.
This one?
Are the same.
Good.
And then same with the other two.
Which other two?
The top right and the bottom left.
I'm going to label them. So this is 1, 2, 3, 4, 5, 6, 7, 8. So which ones are the same?
1 and 7.
1 and 7. Whoops. Are the same. Yeah. Anything else?
Probably 4 and 6. I'm not sure.
4 and 6. Yeah.
5 and 7. No, 5 and what is it?
5 and 7 are the same.
No, it's 2 sevens.
Are these the same?
Oh,
What do we call 1 and 3?
Congruent.
adjacent.
They're not adjacent. To be adjacent, you share a vertex, which they do, but you also share a side, which they don't. They are,
Numbers.
no.
I don't know. I'm trying to think of it. This is so long.
Anybody remember? Two lines cross. Adjacent is still incorrect.
I like the tip of my brain.
Starts with a V. V, yeah, as in vulture.
Very close.
1 and 3 are,
Vertex.
no,
Virtual.
no,
Varying.
no.
Perpendicular.
Perpendicular.
Try vertical.
Oh my God.
And Allie, what do we say about vertical angles?
They're congruent.
That's right. So yeah, they are congruent. All right, so 1 and 3 are the same, 5 and 7 are the same. How do we know that 1 and 5 are the same? Starts with a C,
They share the
Congruent.
starts with a different C. Or a different word that starts with a C. When you used to write CPCT, what did the first C stand for?
There's that.
No. Something parts of congruent triangles.
Um,
No.
Zoe can't see anything that's presenting. I don't know if it's.
Congruent.
No, she can't see it.
Corresponding.
There you go, corresponding. I don't know, Zoe, you can't see anything?
No, not really.
Sounds a little.
You don't see me?
I see you. I just don't see anything you're presenting.
Let me try to stop presenting and present again.
So much creep.
Okay, I can see.
You can see it now?
Yeah.
Okay, so yeah, 1 and 5 are corresponding angles because, you know, they're in the upper right of this parallel line that's been crossed by the transversal. The angles formed by the transversal line are the same if you look at the corresponding part, both where it crosses the top line and the bottom line. So 1 corresponds to 5 and therefore they're congruent. 2 corresponds to 6, therefore they're congruent. Vertical angles are congruent, so
5 above 8.
5 is above 8, yeah. So there we go. We know that. So another thing that we get from this is that when you're between these two parallel lines that are cut by a transversal, we talk about 3 and 5 being alternate interior angles are congruent. Same with 4 and 6, alternate interior angles are congruent. Whereas with 5 and 4, we would say that same side interior angles are supplementary angles. It means they add to 180 because 5 is the same as 1, and 1 and 4 make a straight line. Therefore, 5 and 4, if you put them together, would make a straight line. Is that okay?
Yeah.
All right, so we know that, I'm going to take out some of these. All right, so we know 5 and 3 are the same. Now, if I draw a different transversal, I'll draw it now. Oops. I'll color it red. All right, this one is perpendicular, not perpendicular, but perpendicular. So that means it makes right angles with these parallel lines. So that means this is a 9-degree angle. Now, now we know that this line up here, that 3 and this angle make 90 degrees. So that means 3 and that other angle are complementary. Well, 3 and 5 are the same, right? So that means 5 and that other angle are also complementary, which makes sense. There should be 180 degrees inside of, for the sum of the interior angles of a triangle. 90 degrees is taken up by one of those corners in the right triangle, the right angle. So that means the other two also have to add up to 90, which makes the acute angles of a right triangle complementary angles. So, so we can establish that from what we know about parallel lines, transversals, corresponding parts, vertical angles, and all that, and what the definition of perpendicular is. Okay, so we have that. All right, so that's one of the pieces of knowledge that we have. If we have a right triangle, let me see if this works again now that, nope. Okay, so we have right triangles. So we now know that angle, I'll call this angle B, vertex B over here. And this will be angle A, angle C. Now C happens to be the 90-degree angle in our right triangle. A and B are our acute angles. We do know that the measure of angle A plus the measure of angle B, we just said was equal to half a pi or 90 degrees. That's one of the things that we know. So that's part of it. If you give me angle A, I would know angle B, because it's 90 minus angle A. What's another thing that we know about right triangles? Maybe a relationship between the sides of a right triangle.
The bottom side and the side that's not like slanted are the same.
The bottom, well, in my drawing may not be to scale.
Oh.
So let's assume that A and B may not be the same. But what do we know about how they relate to each other and how they relate to the hypotenuse, the C?
A plus B equals C.
Not A plus, that's not quite right. What is the relationship between A, B, and C? This isn't it. What is the correct?
Square.
Yeah, the squares add up like that. Very good. So that's another piece of information. That's called the Pythagorean Theorem. Okay, so now that relates three sides. So that means if I have two sides, but I'm missing one, I can solve for the unknown side. So if you're missing a side, but you have the other two, you can use that. So that's the other piece of information. The last pieces of information are what we call the trig ratios. So let's say sine of A now that's sine is opposite over hypotenuse. So for A, now I like to think of like a flashlight. A flashlight has a sort of conical beam that comes from it, and now you can imagine that beam shining onto a wall and making a spot on the wall. So it just so happens that the smaller the angle of the flashlight beam makes a smaller spot on the wall. Does that make sense? And if I have a bigger angle for my flashlight beam, I get a bigger spot on the wall. Do you guys follow that?
Yeah.
So in a similar way, when you're in a triangle, the smallest angle opens onto the smallest side. So like if I had an angle like this, triangle, the smallest angle will open onto the smallest side. The medium angle will open onto the medium side, and the largest angle will open onto the largest side. Well, when we talk about, now the reason why I called this angle A up here and this side A, because that angle opens onto that side, like a flashlight shining onto the wall. So little a would be the side opposite to angle A, and little b would be the side opposite to angle B. So for sine, I want opposite over hypotenuse. It's hard for me to write with this thing. Let me shrink this down. Opposite over hypotenuse, which is A over C. Cosine of A is adjacent over hypotenuse, which is the side. So we're talking about legs. So even though C is adjacent to A, it's the hypotenuse. So we're not counting that as one of the legs. But the leg that's adjacent to angle A is side B. So B to C is the cosine of A. And then tangent is the ratio of sine to cosine. So you would do opposite over hypotenuse over adjacent over hypotenuse. The hypotenuses and the bottoms cancel, and you just get opposite over adjacent, which is, in this case, A over B. So that's tangent. It's the two legs, starting with the opposite divided by the adjacent.
Sine A means you go from the angle, not the side.
Yeah, sine A means you go from the angle A, you look opposite, and then you go to the hypotenuse. That's sine.
So when it tells us sine, will it give us the letter for that? It will show us what letter that? Or will we have to like just know?
Let me do an example here. it may say, 27 degrees, 5 and x. So then you got to pick, okay, so 27 is my angle that I know. I can figure out the other one. So this angle I can figure out because this is 90. Those other two have to add to 90. So that must be, what, 63? So that must be a 63-degree angle up there. So I could use 63 as my angle because I know it. But let's say we didn't have that. So they're giving us an angle 27. I have the side opposite, and then I want to know the hypotenuse, right? So the thing that relates the opposite to the hypotenuse is sine. So I would say sine of 27 degrees equals 5 over x. And then I could solve that equation for x. Does that make sense? Now, when you have something like that, where you have a trig ratio, sine of 27 equals the ratio of the sides, 5 over x, if you want to solve for x, you can think of multiplying both sides by x. That would cancel it here. And then you get it over here. And then divide both sides by sine of 27. Another way you can think of that is just kind of like cross multiply. Oops. Just switch the position of the sine 27 and the x, and you'll get x is equal to 5 over sine of 27 degrees. So that's x. So I will mention that on your calculator, you're going to want to check out the screen and make sure it says DEG for degree mode. Otherwise, you should be able to, like this calculator has a DRG button where I can switch between degrees, radians. So I want to make sure I'm in degree mode. What do I do? Hold on. Screwed myself up. All right, so my calculator says DEG. So if I did 5 divided by sine of 27 in degree mode, I would get that x is approximately equal to 11.01345. That's how you do those.
How do we put that in our calculator?
Just 5 divided by sine of 27. There'll be parentheses here. Just make sure that you're in degree mode so that your calculator knows that 27 is in degrees, not radians. You should get about 11. What's that?
How do I put this in degree mode?
Does your calculator say DEG on it, or?
DEL? Yes, second L.
What calculator do you have? Just hit mode on your calculator. And where it says radian,
Oh, gotcha.
is it in degree mode? Like the third line, does it say, is it
Math current float radian function.
the line that says radian, is degree highlighted?
Oh, yeah.
That's it then, you're fine. So yeah, just 5 divided by sine of 27. You get 11.01 something. Did you get that?
No, I'm getting 5.
Hold on. All right, so just hit mode, right?
Yes.
Make sure that you are in degree mode. So I'm going to press enter. Now it's highlighted on degree, and I can quit. And just do 5 divided by sine of 27. You can close parentheses or not. And it should give you 11.01.
Oh, gotcha.
Got it?
Yes.
There you go. So that should work. So you're going to want to remember your trig ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is sine divided by cosine. That works out to be opposite over adjacent. Is that okay? All right, now there are inverse trig functions. Well, I mean, there are other trig functions, I should say, not inverse. They are reciprocal. They are the reciprocal of these. So you have, now, one's called cosecant, one's called secant, and one is called cotangent. Now, it's a little weird because this starts with an S, and this starts with a C. The reciprocal functions are a flip of that. So this one, the one that's the reciprocal of sine starts with a C, and the one that's reciprocal of cosine starts with an S. So it's kind of the opposite of what you might think. But if sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. It's just the reciprocal. If cosine is adjacent over hypotenuse, secant will be hypotenuse over adjacent. And if tangent is opposite over adjacent, cotangent would be adjacent over opposite. Okay? All right, so a couple other things I'll mention is if you have a right triangle and you have angle A, angle B, and C is your right angle. The sine of A, of angle A, would be opposite to A, which is A, divided by the hypotenuse, which is C. But if I did sine of B, that would be from this angle, and opposite of B would be side B, where hypotenuse is C. So what the sine of an angle is depends on which corner you're talking about. So make sure that you're operating from the correct corner. All right, so you have those trig ratios. Now those relate an angle with two sides. So if you don't know a side, but you know another side and an angle, you can use one of these. If you have two sides, but you want the angle, you can use one of these. Pythagorean Theorem was for if you know two sides, but need another side. And if you know an angle, you can figure out the other angle by doing 90 minus the angle, gives you the other angle, because they're complementary. Those are your three sets of relationships that you have your trigs, you have your Pythagorean theorem, and then you have that the angles have to add up to 180. I will mention, before we stop here and let you work on some problems, actually there's two things I should mention. One is, like you said, Gabe, if I'm some guy standing on a cliff and I'm looking out over some area and I got to look at some box on the ground, if I'm looking down at it, we talk about the angle of depression, and that's always measured from the horizontal. So this would be the angle of depression. Let's say that's 15 degrees. That means this angle is 15 degrees, which means that this angle is 15 degrees, because it's alternate interior angles. Usually you'd have to make a triangle then. So you'd have 15 degrees here. That would give you 75 degrees here. And you might want to relate the h to the distance, or maybe this horizontal distance, depending on what they give you and what they're asking. Angle of elevation is the alternate term. If you're looking up at something, angle of elevation is measured from the horizontal. Let's say that's a 30-degree angle. That means this is a 60-degree, 90. If you know the horizontal distance, you can figure out the height using the angle of elevation. So this would be the angle of elevation. It's the same as the angle of depression. Is that okay? All right, so those are special terms that you got to know what they mean. Another thing that you should keep in mind is special triangles. So you don't really have to use this to do your problems. If you're not good with the special triangles, that's okay. Just use the Pythagorean Theorem, the Trig Ratios, and the fact that the internal angles add to 180. But sometimes you can notice right away, like let's say you have a triangle that's like 15 and, I'm sorry, 25 and, yeah, we'll do 15. Let's say the hypotenuse is 15 and this other side is 12. And they want to know this side. Now you could figure it out. You could use the Pythagorean Theorem. So 15 squared minus 12 squared would equal x squared. You might be able to change, like use a trig ratio if you knew one of the angles. But you can also use what's called special triangles. So we have numerous special triangles. There is the 3, 4, 5 triangle. That's a right triangle because 3 squared is 9, 4 squared is 16, 5 squared is 25. So 9 plus 16 makes 25. So that's a Pythagorean triple right there. That's a special triangle. And if I notice that everything over here is 3 times bigger than everything on the right, so 15 is 3 times bigger than 5, 12 is 3 times bigger than 4, that means this x has to be 3 times bigger than 3. So I know that x is 9 in that case, using my special triangle, the 3, 4, 5 triangle.
Have we seen the restroom like that?
Yeah. So we have the 3, 4, 5, that's a special triangle. Another triangle with sides is, I think it's the 5, 11, 12. Is that right? 5, 11, 12. So 121 plus 25. Is that right? Oh, no, I think it's the 5, 12, 13. Sorry about that. I think that's it. So 144, yeah, plus 25 makes 169. So if I square 5, I square 144, I should get 169. So the 3, 12, 13 is another Pythagorean triple triangle. So that's another special triangle. The ones you're probably more familiar with are not with regard to the sides, but with regard to the angles. So there is the isosceles, 45, 45, 90. And then there's the scalene, 30, 60, 90. So these are also special triangles. Now, the smallest side on a special triangle is always denoted by 1. So on the 45, 45, 90, both legs are 1 in length. And the hypotenuse is square root of 2, which is about 1.414. So there's a special triangle for the, and you know that 1 squared is 1, plus 1 squared is 1 again, so 1 plus 1 is 2. The square root of 2 is the square root of 2, so that's one of your special triangles. The other one, smallest side opens onto the smallest angle opens onto the smallest side, so that's the 1. This would be a 2 for the hypotenuse, and this would be root 3 for the side opposite of 60, because 1 squared is 1, root 3 squared is 3, and 1 plus 3 makes 4, the square root of 4 is 2. So that's another special triangle that people typically memorize because they're very common. This one's common because if you have equilateral triangles that are 60, 60, 60, and you cut them into 90-degree angles, or right triangles, then you have a 30, 60, 90. And so it comes up commonly. So these are your special triangles. You can use these. You don't have to. But that's other stuff that some people memorize. All right, so you can use the special triangles, but your main things are the Pythagorean theorem. For your angles, the two acute angles make 90 degrees. The right angle makes 90. Altogether, they make 180. That's another fact about right triangles. And then you have your trig ratios. Sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite of adjacent. So that's how you'll do those first questions on that first right triangle homework. The second right triangle homework is pretty much the same thing. It's just more questions just to refresh your memory after a class period. So I just split it into 2 assignments. So why don't you guys give that a try? That right triangle's 1. You have a question already?
Yeah.
What's your question?
So it says that the angle of elevation to the top of a building in New York is found to be 4 degrees from the ground.
Okay.
A distance of 2 miles from the base of the building. Using this information, find the height of the building.
Okay, we want the height, right? All right, if this is the angle that we have, which is the angle of elevation. So the question was, looking up to the building, your angle of elevation from the ground is 4 degrees. You're 2 miles away from the building. How tall is the building? If you're looking at the top of the building. So we have 4 degrees looking up from the horizontal. 2 miles away, what's the height? That means we want the other leg. So if 40 degrees is my angle in this corner here, I have the 2 legs, right? So what's h compared to my angle? Is that opposite? Is that adjacent?
Opposite.
So I have opposite. And what's my other leg? Is that the hypotenuse? Is that adjacent?
Adjacent.
It's adjacent. So which trig ratio is opposite over adjacent? It is tangent. So that means tangent of 4 degrees is h over 2. And we're measuring in miles. So if I just multiply by 2 on both sides, I get h is equal to twice the tangent of 4. And that should be approximately, you can put into a calculator, 2 tangent 4, 0.1399. I don't know how precise they want you to be. That'll be 0.13985. That's in miles, so I don't know do they want it in miles or feet?
I got it wrong. It was feet.
They want it in feet?
Yeah.
So there are 5,280 feet per mile. So multiply that by the 0.13985 or whatever. And you'll have it in feet. That should be about 738.43 feet. Got it? Good. All right, I'm going to use the restroom because I kind of got to drink too much coffee. I'll be right back, and then if you have more questions, I'll answer those. Okay? All right, I will be right back.
Do I put everyone's names for that or not?
Yeah, we're supposed to.
What if I forget someone? That'd be kind of awkward. Do I do it in like order?
Maybe we just wait and then
Yeah.
time them.
What you gave, so
What
that,
was your initial number?
so what do I multiply that number with by to get the more helping? You turned it up. So what do I multiply this number by?
Is that the
Yeah,
multiplied by?
I'm at like,
5,280. Is that your answer for these?
yeah,
Yeah, multiply by 5,280, because that's the number of miles. That's like miles.
Oh, it's like how many feet in a mile? Okay.
Dude, what was your number that when you first multiplied it before you multiplied it by the mile?
0.1399. Calculator. Are you using your calculator? Can I use it?
I forgot it.
You're such a liar.
I did.
You're such a idiot. You don't like me, just tell me, John.
Nah, I'm trying to be cool.
The calculator, man.
I look at the decimal. What do I multiply?
Okay, let me see what you're doing. Alright. So,
No calculator?
So I have, maybe my number is 9 and 1. How do I put that in my calculator?
I mean,
I'm not a calculator.
Thank you. But like, where you at?
Back.
So.
So it says sine and then capital A. What do I put the angle?
Sign of capital A.
Yeah. Do I just have to find the angle?
Uh,
Do I plug it in for?
is that what they want?
Alright,
Oh,
so
the-
you put
Find
like
an exact value would give it
1
two
mile
decimals.
over.
It gives me A and B, the
To be
sides.
honest, man, like, I can
Gives you the
see
sides? Does
that,
it give you
but-
any of the angles?
No.
And then the question, it wants you to plug in what A equals,
So sine of A.
sine of A?
Yeah.
So then you just have to put the ratio. So what divided by what? So what's opposite of A?
Well, I can help you out there.
Well,
Divided by the hypotenuse? Do you know the hypotenuse?
C. That's all I had with me.
Can you use one of the pieces, one of the equations that we just went over to figure out what C is?
It gives me A and B, so that's just
Yeah.
squared plus.
Yeah, so square them, add them, and then square root, that'll give you C. One thing I should mention, I think I'm still going here, yeah. So when you have a triangle, they might give you some of the angles, angle A, angle B, angle C. Let me do that in different order. This will be angle A, angle B, angle C. Then they'll give you side A, side B, and side C. There's 6 pieces of information altogether. Usually this one's known. This is the right angle. Finding all the pieces, so finding what these 2 angles are, finding what the sides are. This is called solving the triangle. So when they say solve the triangle, they want you to find all 3 angles and all 3 sides. So that's what we're doing with solving triangles. And that just means finding the missing.
When I do 12 squared plus 7 squared, what do I put for C when it's not given to me?
Once you get the sum of those, square root it. Because that equals the square of C. So square root that, and that'll give you C.
This is hello.
Yeah,
Can you open up my exponential equations too? I have a 70 on this. And I can't use weight passes for some reason. It's just maybe give me that.
you can't go into your grade book and click it.
In my grade book, 200 weight passes.
So when it says 13.89,
And I can't, but I can only click the number.
What's that?
so it's 13.89, do I round up to 14?
Does it say to?
You at least,
Got it? What was that? You're locked out?
I can't use late passes on it. I can only click the number and that'll just take me to what I missed, I think. I can't do it.
it just wants the fraction. Doesn't want the,
Yeah, the fraction would be fine. Do you have a fraction?
so ops over hypotenuse would be 12 over 13.99.
So about 14. Yeah, you could do 14 for that.
Well, it was 8, 9, but I rounded the 8 up. Is that right? Or did I just leave the 8?
What were your numbers?
So C ended up being 13.89. Bunch of other numbers.
So that'd round to 13.9. Or just do 13.89. All right, refresh it and try that.
Okay, that works. Thank you.
All right.
So like, how exactly do I do number 2?
What's the question?
It's a triangle,
Yeah.
and it says suppose A equals 11 and B equals 4. And then it just, I'm assuming I just plug a bunch of things into a calculator, but I don't know how to do that. Because then it says find the exact value, give at least 2 decimal places, and there's like a ton of like, whatever we went over.
What are they asking for? C and
All of them,
all of them?
I think.
Are they angles or are they sine of the angles or whatever?
I think they're probably sine, maybe? Wait, hold on. So okay, I think
for the answer boxes, does it say like a letter equals and then there's an answer box, or does it say sign of something?
okay, actually, I think, when I just plug in A here, maybe it says like, again, this one says like, I know this isn't exactly what it means, but this is like sin, and then like parentheses A equals.
Okay, so like let's say this is my triangle and this is angle A, let's say. So if they want sine of A, I would take the side opposite, whatever number's there, divided by the hypotenuse. And I could just put that in as a fraction. So A would be 11, right? Divided by whatever this number is. Do they give you that number?
No.
So you know A squared plus B squared equals C squared, and this is C. So 121 plus 16 is equal to C squared. So that is 137. So C is the square root of 137. So for the sine of A, you could do 11 over the square root of 137.
So I'm still a little, do I like plug that in?
You can just type this, yeah.
Okay. Well, I meant, okay. I'm gonna show you.
Okay.
Because I'm sure this makes sense somehow, but not to me yet.
Okay.
So,
Yeah, so sine of A is opposite over hypotenuse. So that's little a over little c.
okay.
Little a is given to you. That's your 11.
All right. So for the first one, it would just be 11 over that.
Yeah, over the square root of 137.
Okay.
Because I just squared those, added that together, and then square rooted to get c.
Okay.
Does that make sense?
Yeah. But So what do I do for the rest of them then?
So
Like I think we went over what each one means when we were like earlier. So I think I have these written down what they are, but I still don't think I will.
so this was A, right?
Yeah.
And so this was 11. This was 4. Now, if I do 4 squared, I get 16.
Mm-hmm.
If I do 11 squared, I get 121. 16 plus 121 is 137. So C squared is 137. Square root of that is C. Is that okay?
Yeah.
So sine of A is opposite over hypotenuse, so that's 11 over this. And what's your next one asking?
I think is this cosine?
Cosine of A, yeah. So that would be adjacent over hypotenuse.
And then there's a
Tangent,
tangent. Yeah.
that's opposite over adjacent.
And then I don't remember what all these mean.
Secant
Secant. Yes.
is the reverse of cosine. So that's root 137 over 4.
Okay. And then what's this one?
Cosecant,
Cosecant.
that's the flip of sine.
All right. And then
Cotangent is the reciprocal of tangent.
all right. I'm just gonna like.
Does that help?
Yep.
If it gives me one side,
Yeah.
and it wants me to find the other two sides, so this side and the hypotenuse, how do I do that?
Oops.
It only gives me the height side,
So it only gives you the height side. What is that?
4. It gives me
90.
the lower one, the angle is 20.
Okay, you got to find, what is this, A?
That is B.
B?
It doesn't matter.
And this is
That
C?
is C.
Okay. Let's see. Okay, so you're going to have to find one of them first. So we already know what this is up here, right? What is it?
70.
Good. So you got that one. You can put that in already. That's angle B, right? Capital B. For now, let's say you want to figure out, it doesn't matter which one. So let's go with, let's say we're going to figure out C. So I'm going to say, here's 70. I know that 4 is adjacent to 70, and C is the hypotenuse. So that means cosine of 70 is adjacent over hypotenuse. It doesn't matter which one you did. Sine, whichever angle, it doesn't really matter. You just want to have a known side and an unknown side. That way you have one unknown, and you can solve for it. I'm going to flip the positions of those. So C is going to be equal to 4 divided by cosine of 70. And that should give you approximately, oops,
11.69.
yeah, good. So I don't know how precise you need that. 695.
Now just do the square root.
What's that?
So now you can do Pythagorean Theorem.
Yeah, you could use 11.695 squared minus 4 squared would give you b squared, and then square root that to get b. Hopefully that's precise enough. Did they tell you how many decimals or no? right, well, I'm gonna, you two at home, I'll let you guys go. I'm gonna end the thing here. Have a good day.